Welcome to all. See, question 21. Question I am dictating. You should write the question because space problem. Now, before I start, today's class, see, question 21, I will also solve 22, 23. All these are for connected bodies. See, all these are for connected bodies. Connected bodies. But connected body, see, I write here that the connected bodies started in last class. In last class, that is question 20. But what you know what I do? Once I finish a question, I change the number here. Last class what happened is, when I finished question number earlier class, I stopped at question 19. When I recorded for last class, I forgot to change that 19. It was the last class was question 20, which I did not change and written. It is written as question 19. So last class you change it to question 20. You can make one more note. Last class question 20 and today's question, 3 questions, all these are for connected bodies placed on horizontal plane. And connected member will be there. And again I told, if it is a cable or string or rope or wire, it can be only in tension. It can't be in compression. But if it is a rigid member like bar or rod, anything, then it can see a rigid bar can be either in tension or in compression. But cable means it is tension. So once again question, I will dictate now. See, I will dictate the question. Slowly I will dictate. 2 blocks A and B are placed on a rough horizontal surface connected by a cable. So this is the cable. See, this is the cable as shown in figure. Connected by a cable as shown in figure. Sketch given. Then further, weight of block A is 400 Newton, weight of block B is 250 Newton. See later, weight of block A. This is later, not now. See, this is solution, don't see. You see only this much now, question. See, 400 Newton, weight of block B is 250 Newton. Then, further given in the question, coefficient of friction, you should write all these for contact surface of block A with the surface is 0.15. Here mu equal to 0.15, and for the contact surface of block B with this horizontal plane is 0.12. So here mu is 0.15, here mu is 0.12. Now, last time, see, I applied a force this way to pull it that side. Now, I'll apply a force this way. Again, pulling force, right? Then, find the least value of the pulling force P, inclined pulling force P. Last time, that pulling force was horizontal. This time, it is inclined. Okay. See, given pulling force P at 24 degree with horizontal. This is a question. So, this much is given. See, you write the question dictated and copy the sketch. Okay. Then, I will remove this one now. Solution I will go for now. See, leave it now. Question over. Solution. Let T be tension in the cable. See, how? See, when you try to pull this way, surely, see, when you try to pull this way, connected member will be in tension. And, see, tension T as shown. This is a solution. Remember, this is solution I am making now. Not question, solution, tension T. I told, see, regarding this tension T and compression C, I will not explain further. I already told, if a connecting member is in tension, then the tension force, when you consider as a reaction, will be always acting away from the body. See here, from this body, tension away, from this body, tension away. This I told you. From the body outward, see, from the body outward. Whereas, if the member is in compression, then the force will be inward. See, by chance, if it is in compression, not this question, next question. See, then it will be like this. Compression, see. If you see one body here, one body here, see this body, if it is compression, the force will this way, and here see, this way. Or it will act towards the body. If the force acts away from the body, see, here this way, here this way, it is tension. If the force acts towards the body, it is compression. First of all, I should not explain because earlier class I gave introduction where I told very clearly there, see, important concept of tension and compression for connected member, I don't remember, as required for engineering mechanics. Go to that class, study and come back. And one more thing, today is question 21. Little later I will solve 22, 23. Question 20 already over last time. Therefore, I will not waste time explaining many things. You thoroughly study question 20. What all I told you, write, make a fair copy, and then what I tell for this question, I will tell, write yourself. See, little effort is required from your side also. No one can tell you are not writing everything. Why should I write everything? If you have no patience to go through all the classes, not study properly, you don't come to my class. I will tell that I do not want such people who are lazy and simply coming to a class and telling nothing clear, not explained. People who are serious and those who want to gain knowledge, they will correctly follow what I tell. So when in the class, what all I tell, you should take it as an advice and also as an order. See, I got that right for it. When I take this much effort for teaching subject now, right now, engineering mechanics, later, strength of materials and structure analysis all. When that much effort I am putting, I got the right to order. But I will tell it as an advice, not order means harsh language order. See, a student can always take order from a teacher. Okay, now that's all. So therefore, from today's class, question 21, 22, 23, some of the concepts I will already told earlier, you should go through it. Now, see, start. Now, see, again and again, I will not waste time. See, they want to find what? See, you write here, required to find, you should write here, required to find the least value of C, right here, required to find the least value of P, force P, which is required to move the system. So therefore, you have to find the value of P when the system is on the verge of moving. Therefore, it is a case of what? What means I should not tell. It is a case of limiting friction. Okay, sufficient. If now you do not know, if you suppose you do not know what is limiting friction, right now leave the class. Right now. See, friction, it is actually 11th or 12th class. How many times I explained limiting friction? So therefore, write this sketch, show tension, mark weight, and then P 24 degrees, and then see right here. Contact A, see here, let RA be normal reaction here. And here, let RB be the normal reaction. Then, this inclined force P will move the system to left side. Therefore, frictional force will be to right side. Oh, by mistake. I don't know why I put arrow mark here. Okay. And it was for the last question. Okay, no problem. See, your force P will pull the system this way. So both the contact surface this way. It is both the contact surface will be rubbed like this. So frictional force opposite will be to right side. See last time question, the force was this side. The system was moving right side, so I put friction left side. Now the system is on the verge of moving to left side, so friction right side. Now I will not tell. Frictional force here is, limiting force is, you should write mu times normal reaction. Here mu I told just now 0.15. I told just now. See the question. You write the question. 0.15 is the mu into RA is the frictional force. Here frictional force is mu is 0.12 into RB. All this you write. Okay, now start solving. First consider equilibrium. See. Start. Consider equilibrium equilibrium of block, which block? Block, see, class. You should write something here. I won't explain. First you consider equilibrium of block B. Okay, block B. Okay, then very important, block B. Then, okay, why block B? Why block B first? Block B first. Block B first. Class. Actually, one more thing you have to write here. See, after writing all right here, you consider equilibrium of each block separately. This all I wrote last time. See, last time everything was written separately. Consider for one's block A, one's block B, but decide which block first. See, now correctly I told last time. See, if I see block A here, unknown is P1, RA2. This is not unknown because it's in terms of RA. P, one unknown, RA, second unknown, and tension T. Oh, three unknowns are there. But we have only sigma fx, sigma fy, only two equations. So, if you consider block A first, unknowns are three. But if you consider block B first, unknowns are RB and T. Oh, only two unknowns. That's why B first. Last class, remember, the force was the last class question. I'll tell you, I'll remove this one now. Last class question, the question was like this, P. At that time, if I take block B, P, RB and T, three unknowns. Here, only what? RA and T. So last class, I first considered equilibrium of block A, then block B. This class, what I am doing, I am first considering equilibrium of P at 24 degrees. Okay. I am first considering equilibrium of block B, then block A. Okay, start. Right. Further I will not explain because this everything is explained already. I do not want unnecessary waste time now. Okay. Only blocks here, dotted line. This is block A, block B. Here. Weight acting down. How much weight? B, 250 Newton. Okay, right weight here. 250 Newton is weight. The block is moving this side, so normal reaction will slightly shift this side. If possible, you understand or write wherever you want. This normal reaction is RB and frictional force is this way. Frictional force for block B limiting. See, limiting frictional force for block B is 0.12 times RB. Okay. And then one more is there. See, and when I consider block B, don't see here. For this block B, this tension, see, this tension. Later for block A, this tension. Both are equal. So, and see here, we are considering only forces, action and reaction for block B, this one, that is a tension force T. Okay, over. That's all. Start. Now very simple. I will not explain. Sigma Fy0, take upward positive. You get plus RB minus 250 equal to 0. Therefore, RB equal to plus 250 Newton. Okay, RB came. Then sigma Fx0. Take right side positive. Right side, you write right side positive. Minus T, red color, okay, minus T plus 0.12 times RB equal to 0. Now, substitute RB equal to plus how much? Substitute RB equal to plus 250 Newton. You will get the value of tension T. Tension T will come in Newton. Point 0.12, so calculator is not on, 0.12, it is in equation mode. 0.12 into 250 is 30 Newton. Okay. Tension T will be plus 30 Newton. Okay, over. Now correctly see. Now next, Now consider next. Now consider, okay. Now consider equilibrium of block A. Block A, where unknown is P. Okay, write a sketch. Now, next two questions are very simple. See, this is block A. Its weight is acting vertically down. How much weight? Weight is 400 Newton. Okay, right here. 4 space little bigger, I write. Okay. Little bigger. Otherwise, it become confusion. Okay, block A. Its weight is 400 Newton. I write here, upper side. 400 Newton. And then, see, moving this side, reaction, this is, you never bother this one, RA. See, RA. This reaction, RA. And there's a tension here. One more thing. And here, inclined force P is there. See, this is P at an angle of 24 degrees. Now only do one thing. If you got confusion, see, when you resolve left component and up component, the horizontal component is cos, vertical is sine. If you want to make a note, then also there is a tension T here. See, now see, this tension, or why that much? Tension means it should act away from the block. But tension T is already known. How much? 30 Newton. Enter the answer. 30 Newton. And see here, this block, frictional force is this way. This is all told for you. See, this is dotted line. Frictional force is this way. Force of friction, FF, limit for block A is, here see, mu given is 0.12. Here mu given is 0.15. It is 0.15 times RA. Okay, start. Sigma Fx, Fy0 first. In friction chapter, I always do sigma Fy first. Sigma Fy0, upward positive. See, plus P sine, yes, this way. Plus P sine 24, see here, plus P sine 24, plus RA, and then minus 400 equal to 0. You call this as equation number 1. Simplify, you do it. You are engineering student, or you are engineer. It is for high school mathematics. Okay, then someone will tell, he wrote the equation, did not explain how to solve. I will tell, leave my class, don't come back once again to my class. Sigma Fx0, right side positive, see. It will become minus P cos 24 plus 0.15 RA, and then plus 30 equal to 0. Call equation number 2. Then solving 1 and 2, you get the value of the P value in newtons. That's all, question over. I'll give the answer. I'll solve the equation, I'll solve it, no problem. Mode, I'll go to equation mode, table, okay. Equation, shift alpha A, two unknowns. Something went wrong there. What happened is the wrong selection of equation. Shift. Now I can't do it. Mode 1. Work once again. Mode 1. Time waste. Next time I will solve, make ready and come here. This table, equation, shift alpha A for simultaneous 1. Okay. Number of unknown 2. Okay, now correct. Sin 24 equal to next 1 equal to minus 400 becomes plus 400 that side equal to here minus cos 24, 0.15, lastly minus 30. 92.350 Newton. 92.350 Newton. Okay, 92.350 Newton. This is the answer. Okay, question is over. Now I will do one thing now. To save the time, I will write the full solution and start question 22. First I will write it everything because to save the time. Question 20. See, last time two questions are connected bodies when it is pulled. Now it is pushing questions. Two more questions are there. Question 22. Question dictated. See, you should write the way I dictate in the class. Two blocks A and B. See, this is the figure. This is the question. See, this is given in the question. This is given in the question. Given in question. See, there is no place right here. See, two blocks A and B are connected by a rod. See, they told now you cannot connect by a cable. See, it is a rod. They need not tell by a rod. And weight of block A, see correctly, weight of block A is 10 kilonewton and weight of block B is 12 kilonewton. All this you are right in the question. Okay, then coefficient of friction between the between block A and the contact surface is 0.25 and coefficient of friction between for the contact surface of block B with the surface is 0.3. So here 0.25, here 0.3. Then a horizontal push P is applied. Find the value of P when the motion is about to start. So once again, limiting case, you write that one all over. So what all I dictated, you write and copy the sketch. Okay, now write the neat sketch. Okay, start. See, when you apply this way, see, if you pull it this way, see, when you connect the two members by a cable and or any member, pull it, connecting member will be in tension. But when you push it here, connecting member will be compression. This question, I cannot give cable. Why? If I give cable, cable will fold. A will go and hit B. See, A will go and hit B. Now I have to give a rod. See, suppose there is a vehicle. You can put a cable and pull it. You cannot put a cable backside and push it. Backside, if you are pushing, you require a solid member. Okay. Now it is in. So this rod will be in compression right here. So now solution. See, let C be compression force in the rod connecting the two blocks. Okay, over. Now question I will remove. Remove the question. Okay, start. Copy the sketch. See, I told block A weight 10 kilonewton, block B weight 12 kilonewton. Compression means it should come and hit the member. See, it will act to the member. This all, sorry. I am wasting my time explaining something which is told repeatedly in one class, important concept of tension compression. Go there and study and come back. Okay, start. Now, weight down. See, now it is moving. Which side is moving? It is moving to right side. So, RA will be slightly shifted. You don't bother about it. This is RA. This is the weight. See, this is your RB. Okay, now see, weight down, normal reaction RA, compression C. This is no, sorry, this is not C, this is P. This is P. And this is compression. Weight 12 kilonewton. Then friction coefficient is given 0.25. So if it is RA, 0.25 RA is FFA limit. Here, FFB limit is 0.3 RB. This is explained more than 15-20 times. So I won't explain further. Put the sketch. Then right here. Once again remember limiting case. And consider See, again statement, equilibrium of each block separately. Which one first? See, first consider equilibrium of block P. Why block B first class? See here, once again. Block, see, first question, we took equilibrium of block A. Second question, block B first. Third question also block B first. Fourth question, block A will come. Or, see here, block B if you consider, RB, this is, see, yeah, friction is in terms of RB. If you take block B, RB and C, two unknowns. If you consider block A, RA, P and compression, oh, three unknowns are there. You always start from that block where number of unknowns are lesser. So that's why block B. See now, if I take equilibrium of block B, weight 12 kN down, RB, friction. Now see, now it is, last time see, it was pulled this way. Now it is pushed this way. The system will move to right side. So frictional force will be to left side. Again, if I explain further, it is waste of time. The connected two blocks will be on the verge of moving to right side, means both junctions or surfaces friction left side. Okay. Here block B I am doing 0.3 RB. Okay, now usual. Sigma Fy0 plus RB minus 12 equal to 0. RB is 12. Sigma Fx0 plus C minus 0.3 RB equal to 0. Substitute RB, you get, oh sorry, it is not C, I forgot it. You get the value of C. Okay, now consider equilibrium of block A. See here, block A. Weight 10 down. Normal reaction RA. Unknown force P, you have to find out. Then, see, now for block B, see, that force. For block A, this force, C, which is already calculated here, 3.6 kilonewton. And friction is to left side, 0.25 RA. Now question is very simple. Sigma Fy0 plus RA minus 10 equal to 0. RA will come 10. Sigma Fx0 plus P minus 3.6 minus 0.25 RA equal to 0. Okay, highlight here. Okay, substitute RA equal to plus 10 kilonewton. You will get the value of P, which will make the system on the verge of moving. Okay. Now, last question for the first question, horizontal pull, inclined pull. Second question, the first and second question. Last class, first question, question 20 was horizontal pull. Today's first question, 21, is inclined pull. 22 is horizontal push. Now I am going for inclined push. Last question, over. Question number 23. 23, I will, again to save the time, I will write everything and start. Again to save the time. Now, today's class last question, question 23. See, again, question dictated. See, right. Figure shows, put the sketch. Figure shows two connected bodies or blocks, two blocks A and B connected by a rod. Then, in the question, weight of block A is 6 kilonewton and weight of block B is 4 kilonewton. In the question given, then coefficient of friction for all contact surface is 0.4. That means here also 0.4, there also 0.4. See, in earlier question I changed it. This time both contact 0.4. Okay, 0.4. That is even here and here, both the places 0.4. Then find the least value of inclined push P required to start motion. Over. Right, once again sketch here. See. Now over. Question copy. See, A 6 kN, 4 kN. See, now again, since you are pushing, the rod will be in compression. Right there. Let C be compression force in the rod connecting the two blocks, compression. Already explained. Okay. Weight 6, weight 4. Then RA, RB. See, push this way. So system will move left side. Friction force is to right side. How much? Here at A, limiting friction is 0.4. Here also 0.4, but here 0.4 of RA, there 0.4 of RB. Last time these numbers are different, but this time common. But RA, RB different. Okay. Right. Limiting case over. Consider equilibrium of each block separately. Which one first? See here. Now, if I take A first, or A, RA and C, two unknowns. If I take B, RB, C and P, oh no, three unknowns. Or you start from block A. See, first question last class block A, second question first block B, third question also block B, fourth question block A. Study all these questions, you will understand which one first. Okay. First class, why first? Reason is less number of unknowns. See here, only block A, 6K and down. RA, FFA, right side, FFA limit, 0.4 RA. And see, this compression force C. I think I don't have to explain. Sigma Fy0 plus RA minus 6 equal to 0. RA will come 6 kilonewton. Sigma Fx0, right side positive, minus C plus 0.4 RA equal to 0. Substitute RA 6 kilonewton. Compression will come 2.4 kilonewton. Okay. Now consider equilibrium of block B. See, block B, this way. Weight 4K and down. RB up. Friction right side of 0.4 RB and the compression force this way. But by this time, you know the compression force, 2.4, and inclined force P. Now remember, if you want, you can do one thing. See, horizontally left component, vertically down component. This is cos, this is sine. If you are interested, okay, start. Sigma Fy0 plus, start from unknown first, minus P sine 30 plus RB minus 4 equal to 0. Equation number 1. You simplify it and take the constant to other side. It is high school mathematics. Okay. Sigma Fx0, right side positive. Okay. Minus P cos 30 plus 0.4 RB plus 2.4 equal to 0. Equation number 2. Solve 1 and 2. You get the value of P. Over. Solve it. You get the answer. So today's class, I consider last class and today's class, question 20 last class, 21, 22, 23 here, systematically connected blocks, 2 times in contention, 2 times in compression. When tension? When it is pulled, any side, either pull that side or this side. If you pull a block, connecting member will be in tension. Next 2 questions just now, push. So push means the connecting member will be in compression. You can have experiment and check it. See, you place something here, place 2 members, push it. Naturally, this will be compressed. Okay. So you solve all these questions. Next class, same connected body, some 2-3 interesting questions are there. All of them are academic. But for those who want to learn structural engineering, those questions are useful because your concept will be more and more clear. Okay, that's all. Thank you. Next class we will meet.